1.5, make decisions using trigonometry. So we need to decide which formula to use based on the type of triangle the situation represents. So our first question is the triangle right angled? If so, we go this way. So let's talk about the triangle being right angled. So if it is right angled, we have to ask ourselves, does the question involve any angles or is it just side lengths? Okay, so if it involves angles, we use trig ratios. So what this is SOHCAHTOA. And then if it doesn't involve any angles and it only involves side lengths, then what we would use is Pythagorean's theorem. Okay, so that's one situation. So right angled would be over here. Okay, this situation. Now, is the triangle right angled? If it's not, then what we have to do is we basically have to see whether we use sine law or cosine law. So, do you know a side and its opposite angle? In other words, do you know a matchup? If you know like a matchup, which is a full ratio, for example, A over sine A, right? So the angle and the opposite side length, then what we're going to do is we're going to use the sine law, the sine rule. And then if not, then we use the cosine rule. So example 1, a 10-meter ladder leans against a wall. So already I know there's some wall, there's some ground, walls and grounds meet at 90 degrees, and then there's a ladder. So this is the ladder, like this. So a 10-meter ladder. The top of the ladder is 9 meters above the ground. So this is the top of the ladder, and then this will be 9 meters above the ground. Safety standards call for the angle between the base of the ladder, so the base of the ladder is down here, and the ground, which is here. They want this angle to be between, the guideline is 70 degrees to 80 degrees. And then that would make it safe. So the question is the ladder safe to climb? So instead of subbing in a 70 or an 80 here, what we're going to do is we're going to actually solve for the situation where the opposite side is 9 meters and the hypotenuse is 10 meters. And then afterward, we can compare it to the 70 to 80 guideline. So I went ahead and labeled the opposite. We can label the adjacent, even though we don't know that side length. And I labeled the hypotenuse. So we can go down this flow chart. So is the triangle right angled? Yes, it is. Does it involve angles? Yes, it does. We have to find the angle. So use trig ratios. Okay, so trig ratios, I already kind of started this, opposite, adjacent, and hypotenuse. But the trig ratios involve SOHCAHTOA. So we have to decide which trig ratio we're going to use. Are we going to be using sine, cos, or... So the two side lengths that we're dealing with are opposite and hypotenuse. So we're going to be using sine. So sine A equals opposite over hypotenuse. Okay, and we'll just call that A. Sine A equals, we're going to sub in the value for the opposite, which is 9. And we're going to sub in the value for hypotenuse, which is 10. And we get sine A equals 0.9. So we haven't solved for A, we've solved for sine A. So what we're going to do in order to reverse that sign, we are going to sine inverse both sides. Okay, it's quite obvious that 0.9 is not our angle. Okay, and then we get A equals sine inverse of 0.9. We get 64 degrees. So if our angle is 64 degrees, and the guideline is that the angle needs to be 70 to 80 degrees in order to be safe, does our 64 degrees lie between 70 and 80? No. So therefore, make this darker, therefore, the ladder is not safe to climb because the angle it makes with the ground is 64 degrees, which is not between 70 to 80 degrees. Example 2. A cable car stops part of the way across an 86-meter wide gorge. So the gorge is 86 meters. Okay, and then there's like some cable car, and maybe you sit here. People are sitting down, okay? Or standing up. The cable holding the car makes an angle of depression of 57 degrees at one end and an angle of depression. Okay, so I know I put this on kind of like a round cable. That's okay. So on one end, we have an angle of depression. So again, this angle of depression is going to be from a horizontal, and it's going to be looking down. Okay, and that angle of depression is 57 degrees. And the other side is at an angle of depression of 40 degrees. So again, go from a horizontal, angle of depression, 40 degrees. The question is, how long is the cable that holds the car and round to the nearest meter? So we are going to be using the Z law first. So if you can see here, and I'll do this in bright purple. This is the Z rule where these two angles are the same. So this is going to be 57 degrees. And now this is the backwards Z where these two angles are going to be the same. So this can also go like this. Oh, I'll redraw that. Okay, so this one is also going to be 40 degrees. And if we label this A, let's go darker, A, B, C, angle B is going to be 180 degrees minus 57 minus 40. Okay, and in our calculators, we get 180 minus 57 minus 40, we get 83 degrees. So if you're comfortable with this drawing, you can keep it. If you want to clean that up, I'm going to redraw mine so that I don't have the cable car, the extra angles, the people there, okay? So I'm going to relabel it as triangle ABC. This is 86 meters, 57 degrees, 40 degrees, and this is 83 degrees, okay? So now that we're dealing with this triangle, let's go back to that flowchart and see which law we have to use. So, is the triangle right angled? No, our three angles are 83, 57, and 40. So, no, it's not. Now, the question is, do you know a side and its opposite angle? Okay, let's scroll back down. So, I'm seeing the side 86, and we know the opposite angle. So yes, we do. So since that's a yes, we're going to use the sine rule. Okay, so going back down here, we want to know how long the cable is. So the cable has two parts to it. The cable has the part going up and then the part going down. So we're going to have to use the sine rule twice. So let's start with side A. So because we're solving for the side, we're going to use, and I'm just going to box this off. There we go. Okay, A over sine A equals, and then our full matchup here is going to be B over sine B. Okay, we don't know what A is, but angle A is 57 degrees, so sine 57. And then B is 86, and then sine B is going to be sine of 83. So what we want to do now is we want to take this sine 57 and cross multiply it up so that the A is now alone on this side. So we get 86 sine 57 over sine 83. Okay, don't forget about that denominator there. And we get the length of that portion is going to be 72 point, let's round to 7. And that's going to be measured in meters, I believe. Yeah, meters. Okay, so this side is 72.7. Now let's solve for side C. So again, we're solving for the side length. So this is going to be C over sine C. And then I'm going to have B over sine B, since that's our full ratio that we know. Okay, so side C we don't know, so we leave it as a C. And then angle C is 40 degrees right here. So we get sine 40. And the B over the sine B, we already did all the work for this. So we can take a look at our previous calculation, or we can go back to the drawing and be like, okay, side B is 86 over sine, and then the angle B is 83. Okay. So to get C, we want to cross multiply the sine 40. Okay, so we get 86 sine 40 over sine of 83. Okay, and when we put this all into our calculators, we get 55.7 meters. So going back up to the original question, it says, how long is the cable that holds the car? Okay, so we have to do total length of the cable, 72.7 plus 55.7, and we get 128.4. So we can say, therefore, the cable is 128.4 meters long. Example 3. A sewer pipe for a new subdivision has been laid underground. A connection is made to the main service pipe at either end of a 4.8 kilometer stretch of road. So it's going to be this long. One pipe, 2.5 kilometers long, makes an angle of 72 degrees at one end of the road. So 72 degrees, this pipe is 2.5 kilometers long. Okay, at one end of the road between the two stretches of pipe. So we'll obviously finish our triangle. Let's just call this A, B, and C. A, calculate the length of the second pipe, which is this one right here, that will connect the first pipe to the other end of the road. Okay, well, it's saying length. The only length that we don't have is A. Okay, and then what is the measure of the angle made by the connecting two pipes, we're then going to solve for B. Okay, let's focus on A first. So let's go up to this. Is this a right angle triangle? No. Okay, we can't assume that it's a right angle triangle. So we say no. Do we know a side and its opposite angle? AKA, do we have a matchup? Well, 72 degrees, we don't know A. 4.8 kilometers, we don't know B. 2.5 kilometers, we don't know C. So we have three values, but we don't have any matchups. So I'm going to go no. Therefore, we use the cosine rule. So if we're looking for the side length A, we're going to use A squared equals B squared plus C squared minus 2BC cos A. So we're solving for A squared. So side B is going to be 4.8, right? It's opposite angle B. So 4.8 squared plus side C is going to be 2.5 squared, okay, minus 2. We want BC again, which is going to be these ones repeated, 4.8, 2.5. Then we have cos, and we want to fill in angle A, which is our 72 degrees. So if we do 4.8 squared, we get 23.04. If we do 2.5 squared, we get 6.25. And remember, this term, this is one term, and it's all multiplied. So bring down that negative sign, and then we get 7.42. Okay, and now we can go ahead and add these up. 23.04 plus 6.25 minus 7.42, we get 21.87. Okay, it wouldn't make sense if we have the kilometers of 2, 4, and 21. 21 is way too big. That wouldn't make a triangle. So we can't forget to actually take off the square on the A value. So we want to square root it. And we get 4.7 kilometers. We'll go ahead and round to 1 kilometer, or 1 decimal. So let's label this 4.7 kilometers. Okay, now, so that's A. B is, what is the measure of the angle made by the connecting two pipes? So that's going to be angle B. So now we have all three side lengths. Okay, so here's the thing. Going through this again, is this a right angle triangle? Obviously, it's still not a right angle triangle. Do you know a matchup? So we could use this as a matchup now, or we could use cosine rule. Okay. Just to switch it up, I'm going to use cosine rule just so that we can practice that. So if I want to solve for angle B, I'm going to write cos B equals B squared minus A squared minus C squared over negative 2AC. Okay, so just a reminder, at this time, we have so many values in our triangle, we could use either sine law or cosine law. So it would be up to you how you see it and what you're more comfortable with. So let's go cos B equals, side B is 4.8, so 4.8 squared, minus side A, which is 4.7 squared, minus side C, which is the 2.5 squared, all over negative 2, 4.7, 2.5. Okay, remember, these are going to be the same number, and these are going to be the same number. So these two are going to be duplicated. Okay. So cos B equals, so we've already done a lot of this work. 4.8 squared is at 23.04 minus 4.7 squared. This is a new one. So 4.7 squared is 22.09 minus 2.5 squared. We already did it. It's 6.25. And if we put negative 2 times 4.7 times 2.5 in our denominator, we get negative 23.5. All right, so let's do cos B equals, let's calculate the numerator. So 23.04 minus 22.09 minus 6.25, okay, which is this expression here. Negative 5.3, we keep negative 23.5 in the denominator. And when we go ahead and divide those out, we get negative 5.3 divided by negative 23.5. 0.225531.914. Okay? That's clearly not an angle. We need to inverse cos both sides. We always have to inverse cos when we're finding an angle. So, angle B equals 77 degrees. Okay? So, going back up here, let's do therefore statement. Okay? Therefore, the length of the second pipe is 4.7 kilometers and meets the first pipe at an angle of 77 degrees.